Let's examine number patterns and sequences. We're going to explain what number patterns are. We're going to look at finite and infinite sequences, arithmetic sequences, and geometric sequences. So number pattern is a specific sequence or pattern or arrangement of numbers. Here are some examples of number patterns. Here we have -3, 1, 5, 9, and 13. And then you have 1, 2, -4, 8, -16. So there is a specific sequence or pattern in the arrangement of these numbers. When we look at finite sequences, we have one that has a first and a last term. And an infinite sequence has a first term, but it continues indefinitely. We typically end with an ellipsis, which is 3 periods together. When you see these 3 periods together, it means that the sequence continues infinitely. So that's why we have this as an infinite sequence. So an arithmetic sequence is one that exists by adding the same value each time. So if we look at this, for example, look at 4, 9. So the difference between 4 and 9, you have +5 here. 9 and 14, you have +5. 14 and 19, you have +5. 19 and 24, you have +5. So this is an arithmetic sequence because every time you're going to add 5 to the previous number in the sequence. Now let's look at getting the next term in each of these sequences. So let's look at from -3 to 2. So what do I add to -3 to get me 2? So one way to go about it is you can say 2 minus -3. So that's going to give you 5 right here. From 2 to 7, which is 7 minus 2, you get a 5 here. 7 to 12, you have 5. 12 to 17, you also have 5. So the next term in the sequence is going to be achieved by adding 5. So we're going to get 22 as the next number in the sequence. So 3 to -5, so let's go ahead and say -5 minus 3. So we have -8. -13 minus -5, we have -8, and that is so from here to here, from here to here, from here over to here is -8, and then -21 to -29 is also -8. So the next term in this sequence is going to be also adding -8. So that's going to be -37. Now a geometric sequence is one that is arrived at by multiplying the same value each time. So if we look at this example, for example, here, we look at this sequence here, for example, we see 2 times 2, so we have multiplied by 2. Here also we multiply by 2. Here we also multiply by 2. So to get the next number in the sequence, you're going to multiply the previous number in the sequence by 2. Let's look at these examples here. We want to find out the next term in each of these sequences. So how do I get from 4 to 2 as a geometric sequence? Here we multiply by 1/2. Then here we also multiply by 1/2. We multiply by 1/2. Here we multiply by 1/2. And then also we're going to have to multiply by 1/2. So we have 1/4 times 1/2 is 1/8. So the next term in the sequence is going to be 1/8. So from 2 to -6, we multiply by 3, by -3. -6 to 18, we multiply by -3. From -18 to -54, we multiply by -3. And -54 to 162 we also multiply by -3. So one of the things you can observe is the signs keep alternating. So to get the next term in this sequence, we're also going to multiply by -3. So 162 times 3 is going to give you 486. So it's going to be -486. So this is just an introduction to sequences with a focus on arithmetic and geometric sequences.